got other videos on how to integrate and differentiate the inverses of sine, cosine, and tan. But in this one, we've got a naughty x here, which slightly complicates things, but it's very much the same. So we're going to be using integration by parts, which is uv minus v du dx. Let's let u equal the inverse of sine 2x. So you're going to have sine minus 1, 2x. That differentiated is going to be du over dx, which is 2 over the square root of 1 minus 2x squared, which simplified would be 2 over the square root of 1 minus 4x squared. So we've got our du dx, and we've got our dx here and an x. So we're going to make that x dx dv equal x dx, which is our remaining components, and we want to integrate those. So dv equals x dx, and that integrated would be v equals a half x squared. So let's now substitute all of this into here. So we're going to get a half, where's it? uv, so this, so a half x squared sine minus 1 2x minus the integral of a half x squared multiplied by 2 over the square root of 1 minus 4x squared dx. I've put a dot here. I think that you only really experience the dot product and stuff at university, but it's commonly used to express a multiplication, and I'm using that quite loosely at the moment. But that's why sometimes you might see me do a dot, but it's that, or if I just did a multiplication, it'd be the same. However, I don't want to confuse it with the way that I draw x's with this pen. Anyway, so we now have this naughty thing here that we need to simplify. So I'm just going to ignore this part, and this is going to become minus integral of x squared over 1 minus 4x squared dx. So now we have to integrate this all again. We now first let u equal 2x, and we know that x would equal u over 2. All I've done is rearrange that, and that means then if we can differentiate it, it would be dx equals half du. We also have x squared, which equals u squared over 4. And 1 minus 4x squared, which could equal, if we just rearrange this, multiply 4 to that side, we can substitute this in for u squared, which would then be 1 minus u squared. So this would then become the integral of u 2 over 4, the square root of 1 u squared dot half du. So this multiplied by each other. If we now simplify this out a little bit, you're now going to get 1 over 8, which is the integral of u squared over 1 minus u squared du. So we can now use an identity, which is the integral of u squared over the square root of 1 minus u squared du is the same as the integral of 1 over 1 minus u squared square rooted minus the square root of 1 minus u squared du. So we can now substitute that in, and we should now get sine minus 1 u would equal, sine minus 1 minus a half u square rooted by 1 minus u squared plus c. So now we plug this back in to our earlier expression, which is here, and therefore it's then going to be a half sine minus 1 2x minus a half 2x square rooted by 1 minus 4x squared. And this is going to be an eighth sine minus 1 2x minus an eighth x all square rooted to 1 minus 4x squared. So we've just taken that. We can now plug that into here. So we've got this, and now we've solved this part, so we can now bring it all together. So you're going to get, let's see if I can fit it in, a half x squared sine minus 1 to the 2x minus an eighth sine minus 1 2x minus an eighth x all square rooted to 1 minus 4x squared. And you could, for good measure, simplify this a little bit. You can pull out a half x squared minus an eighth, and then you have sine minus 1 2x. Sorry, that's a bracket, plus an eighth x all square rooted to 1 minus 4x squared, and then of course don't forget the plus c. So that's a pretty nasty integral, lots to keep track of, but yeah, it's basically integration by parts on steroids.